Can you actually be addicted to social media? Is social media akin to drugs? Should social media addiction be considered in DSM-5? Oh! Hey there, and welcome back to NeuroScIQ, the best place on YouTube to increase your neuroscience IQ. Today, we're going to talk about something that's probably very familiar to you. Just based on the fact that you're here on YouTube with us and joining us on this video today, we're going to be talking about social media and its addictive properties. Ooh, I got another like. Now, I'm not here to bash social media or anything because, like practically everything in this world, social media has its pros and cons. So today, instead of just ripping on social media and talking about how it's bad and addictive and all these things, we're going to look at it through a more critical lens, and we're going to look at it with the main goal as to whether it should be actually considered as an addiction in the DSM. For those of you that don't know what the DSM is, it's the Diagnostic and Statistical Manual for Mental Health Disorders. So basically, it's a book that physicians use to define psychological disorders, and it lists a set of rules that psychiatrists can use to diagnose disorders, things like schizophrenia, anxiety disorders, mood disorders, personality disorders, so on. They can be found in the DSM, and psychiatrists use the rules so that we have more of a standardized diagnostic method. Now, before we talk about whether social media is addictive or not, we need a basic understanding of the way addiction works in the brain. So we're first off going to look at the addictive pathways in our brain and how that all works for general addiction. Now, one of the key molecules involved in addiction is dopamine. Dopamine is a key neurotransmitter in your brain, and there are three main pathways that are important for dopamine. There's the neurostriatal dopaminergic pathway, as well as the mesocortical dopaminergic pathway, and the most important one for today's talk, the mesolimbic dopaminergic pathway. These three pathways play different roles. So we have the neurostriatal pathway, which is involved in movement and sensation, and so disruptions in this pathway are related to things like Parkinson's. The mesocortical pathway is for attention and learning, and the mesolimbic pathway is for pleasure and addiction, which is why it's so important for today's talk. So euphoria, or feeling good, comes from the dopamine molecule. Obviously, we like feeling good, and so that is what makes the dopamine molecule have its addictive property, and that's what makes things addictive. If we have dopamine release in the brain, we feel good, we want to experience that feeling again, and that's where addiction comes into play with the mesolimbic pathway. Things like nicotine, cocaine, these heavy-duty addictive drugs involve the dopamine mesolimbic pathway. Even coffee involves this pathway, which gives it some of its addictive properties. And also marijuana affects this mesolimbic pathway, which can make it addictive as well. And we're going to discuss marijuana and its effects on the brain in an entirely different video. But let's just stick to addiction for now. So I already mentioned that the mesolimbic dopaminergic pathway is the key pathway involved in addiction, and that runs from this area called the ventral tegmental area down in the brainstem all the way up to a region in the forebrain called the nucleus accumbens. So typically we have these dopamine molecules being released from the ventral tegmental area to the nucleus accumbens, and we experience euphoria. This pathway was also discovered kind of by accident, which sometimes happens with science. So basically, these two scientists by the names of Olds and Milner were doing studies on rats, and so what they were studying was actually arousal by using electrical stimulation through implanting electrodes into the brains of the rats. And so they implanted electrodes into rat brains, various different locations, and what they found was actually that after even just one stimulation of a certain area, the rat seemed to like going back to that area. Even though this was like a plain box, the rat would go back to the spot where it was stimulated, like an addiction. So keeping the ball rolling, Olds and Milner thought to themselves, whoa, what if we allow the rats to self-stimulate? So they created a whole new apparatus where basically the rats were contained in the box, and now there was a lever available. And when the rats press the lever, they can self-stimulate. And so this is called intracranial self-stimulation. And so what they saw was that as soon as the rat realized that by pressing the lever it would self-stimulate, the amount of lever pressing skyrocketed to the point where they stopped thinking about even food and water. They would just sit there and press the lever over and over again to receive self-stimulation. And these areas were what is now known as the mesolimbic dopaminergic pathways. Now keep in mind, this didn't happen for every region that they implanted an electrode in. Some of these regions caused an increase in lever pressing, and some of them totally abolished lever pressing. And so they called these regions the ICSS, which is intracranial self-stimulation positive regions, which are regions that cause an addiction to lever pressing. And then they had the ICSS negative regions, which caused a cessation of lever pressing. Anyway, sticking to the addictive regions, or the mesolimbic dopamine pathway, there was a particular area called the medial forebrain bundle, which was a bundle of axons projecting from the ventral tegmental area to the lateral hypothalamus. Now, if you remember from our video a couple of weeks ago about caffeine, the lateral hypothalamus promotes homeostasis, and so it's involved with this whole drive reduction theory. So if you feel thirsty, your hypothalamus is what's going to make you go drink water to reduce that drive. So we have this medial forebrain bundle going from the ventral tegmental area to the lateral hypothalamus, which plays a role in dictating what we should do next. If you didn't watch our caffeine video, it'll pop up somewhere in the corner. Many neuropsychological studies tend to implement drugs that mimic other drugs. And so for dopamine, these two drugs were haloperidol and amphetamine. So what they did was amphetamine, remember we talked about antagonists and agonists, amphetamine is an agonist, which means it acts like dopamine. So they injected amphetamine into this area and saw that it caused an even higher rate of lever pressing. When they injected haloperidol, which is an antagonist, which means it blocks the activity, we saw a reduced amount of lever pressing. So this suggested that dopamine is actually what is in charge of the reaction of increased lever pressing. With all this being said, that's how we found the areas involved with addiction. And that's how they figured out that the key molecule involved was dopamine, our euphoric molecule. So dopamine is said to cause euphoria and facilitate addiction at the end of the day. How does this all come back into the topic of our video, social media addiction? Ooh, another like. Well, the hedonic hypothesis basically says that we continue performing certain behaviors to keep ourselves at a baseline. A lot like homeostasis. We want to maintain a certain basal level of dopamine. And so during that state where we are on a low, that's when we crave a drug to compensate. Remember in our caffeine video how we talked about sensitization and desensitization? So we have all this dopamine being released, and what's happening was with these high levels of dopamine, next time the person takes that drug, the effect is in fact lessened, and this is called desensitization. Now, the reason that this is happening is because on the initial stimulation, you experience a great high. But after many stimulations, the body adjusts and tries to return to homeostasis faster. And so the opponent process, labeled here as B, increases. And the opponent process can be things like enzymes that break down the drug or reuptake of the released neurotransmitter. So while on the first stimulation, a lot of dopamine is released that can act on all the receptors and cause a large effect with the slow reuptake and slow degradation, after many stimulations, this reuptake and degradation of the dopamine increases, and so the effect is lessened. So when the person's off the drug, now all of a sudden, their baseline levels of dopamine feel subpar. And so what they're going to try to do is compensate. They experience withdrawal, they feel sad, and they want more dopamine to be released to achieve this baseline. And that's the hedonic hypothesis of addiction. Interestingly enough, we're going to cycle this all back around to our topic of social media. And interestingly enough, it has been shown that these areas, our mesolimbic dopamine pathway, are actually activated during social media use. So those days when you find yourself cycling through Instagram, Twitter, Facebook, Instagram, Twitter, Facebook, Snapchat, back and forth, back and forth, back and forth, looking at the same posts over and over, you may actually just be trying to get your dopamine to a homeostatic baseline. Another like. It's said that every notification we receive on our phones sends dopamine to our brain. Now the thing is, we don't actually know why this happens. Why is it that a notification on social media is causing dopamine release? A lot of people think it's because we are social animals. And so we have evolved through time to be social, to communicate with one another, and so that's a rewarding stimulus. Just like we evolved to drink water to stay alive. We need some sort of reward when we drink water, and so we get dopamine release with that whole pathway. Same thing with socializing with others. Being social and socializing and working together with people as teams helped us move forward as a species. This is why they think that when we get a notification or we get another like, we have dopamine release in our brain. And that is why you keep picking up your phone to check and see, did somebody like? Because we want to get our dopamine to this sort of basal level. And maybe it's been a while since you checked your phone, no notifications, so you pick it up to check again to see if you'll get that positive reinforcement, that response, that dopamine release from your ventral tegmental area. Now, like I was saying, it's unknown if this is just the fault of social media, maybe it's because we get all these banners, these logos, these things popping up, making it seem all exciting. Some scientists have also looked into whether it's just the fact that we are egocentric. In fact, studies at Harvard using MRI imaging had people think about themselves, and what was shown was that these dopaminergic pathways, specifically the mesolimbic dopamine pathway, were activated while individuals thought about themselves or talked about themselves. And so maybe just the act of promoting oneself on social media is what is making it addictive. On top of all that, social media has been shown to have the effects of withdrawal, tolerance, and even some of the negative repercussions we see with drug use and drug addiction. So that begs the question, is social media a drug? Now, it may seem convincing from what I've shared with you that social media should be treated like a drug, and social media is in fact addictive. I mean, we said it has similar neural correlates to drugs. We've seen similar effects to typical drugs like withdrawal, tolerance, and negative repercussions. But is that enough to add it to the DSM as an addiction problem under the section for substance use disorders? If you think you're a social media addict, maybe you should start monitoring your use. Lots of phones have it on settings where you can put on some sort of time limit for the day, and so you don't overuse. Also, just make sure you're using social media for the right reasons and you're not just going back over and over again to check likes and stuff. It's okay to use it to connect with people, but make sure it doesn't take over your life. The bottom line is just make sure social media is not taking over your life. Make sure you're actually social in real life and not just glued to your phone. That's it for this week's episode. Make sure you join us next week. I'll leave you with one question for the rest of the week. Comment down below if you think that the future DSM-6 should include internet addiction disorder. Comment down below, make sure you like, comment, subscribe, and I hope to see you next week. Make sure to like, comment, subscribe, and share this video with all your friends. Hope to see you next week. Remember, this is the only channel where you can increase your NeuroScIQ.